Hello, my ninja warriors. Welcome to yet another power packed session. And today's session is dedicated to problem solving PYQs, indefinite integration of JEE in 2024 April attempt. So, let us have a look what happened in April attempt, right? So, April attempt, mein you can see indefinite integration ke there were 5 questions, right? So, what does that mean? There are 50% chances that you are going to get a single question from indefinite integration in your upcoming JEE main, right? So, basically, yes, indefinite integration, if you see this, it is a low weighted chapter, but just understand without indefinite integration, there are a few upcoming high weighted chapters from integral calculus. What are they? Definite integration, area under curve, and differential equation. All three are very important, right? And this requires basics from indefinite integration. So that's why indefinite integration, although it is a low weighted chapter, but it is very important. Okay. So we will only focus on April attempt questions in today's session. Let us start with the very first question. Okay. Now this question is from, okay, let me just do one thing. 5 questions, I will tag all 5 questions. So this question is from the topic recurring integrals. Okay, so this is a little bit lengthier question. Recurring integrals. Okay, topic name I will write. Then next question is appearing from, okay, so basically it is a substitution form wherein if you can create tan x in the denominator and sec square x dx in the numerator. This is of that type. Question number 2. Question number 3, again substitution. Okay. All right. Question number 4. I mean similar type basically. If you can denominator में you can create cot x and numerator में you can create cosec square x dx. All right. And the next question is actually good question. Again, basic substitution, but standard question. So substitution again. Okay. Okay. Substitution. Then we are having our last question, which is, okay, of the form denominator is again a sin x plus b cos x, and the numerator is again p sin x plus q cos x. Okay. So numerator in this can be written down as a times denominator plus b times derivative of denominator. That's how it is done. And yes, I guess all 5 questions are there. So we'll start with this question. Yes. Okay, because the first question is a little bit lengthier. So let's start with this small question first. Okay. So 1 upon a square sine square x plus b square cos square x. So how to solve it? Let's understand. So first of all, what I'm going to do is I'm going to take cos square x common, or you can say that multiply numerator and denominator by sec square x. So it is going to become sec square x dx because I want sec square x over here. If I multiply sec square x in the denominator, what do I get? A square sine square into sec square. That means sine square by cos square. So a square tan square x. Basically, we are dividing by cos square, right? And this is b square integral dx. Now you have to put tan x equals to t. So tan x will be equals to t in this particular case. Tan x is t, correct? The moment you put tan x t, obviously sec square x dx will become dt. So your integral now will become dt upon, okay, a square t square plus b square integral. Perfect. Okay. Now why don't we do one thing? We take a square common. So dt upon, if I take a square common, it is going to be t square plus b by a ka whole square. Integral is there. Now you know the formula. Let me just write down for you. 1 upon x square plus a square dx. Integral is 1 upon a tan inverse x by a plus constant. Okay. So this is going to become 1 upon a square as it is. 1 upon b by a tan inverse t upon by plus c. Now let's replace. So a cancel the 1 upon ab. Tan inverse. T is again tan x upon b by a. Okay. Plus constant. Now if I look at this clearly, AB is coming out as 12. So AB is 12 and A upon B. Can you see this is A by B? That is coming out as 3. So A is equals to 3B, right? So A is equals to 3B. So basically it is 3. Now how will we get 3? Tell me. It is AB is 12. So 3 into 6 by 2. Yes. A is 6 and B is 2. Perfect, right? So 6 sin x plus 2 cos x. Now the maximum value of A sin x and B cos x. The max value, you know the formula, square root of A square plus B square. So from here, maximum value of this will be square root of 6 square plus 2 square. 36 plus 4 is root 40. Option A or option 1 you can say is absolutely right. Okay, good question. Next question, similar type. In here, again, sine square x can be written down as 6 cos x square x, right? And we know that derivative of cot x is minus cos x square x, right? There is a minus. So minus is already there, na? 1 minus cot x. So what we will do is, we'll put 1 minus cot x is equals to t, so that we will get plus cos x square. Because if you differentiate, you're going to get minus minus cos x square, na? So cos x square x dx is equals to dt. So 6 dt upon t square ka integral, that will give you minus 6 by t plus constant, minus 6 upon 1 minus cos t plus c is your I of x. Now, as per the question, I of 0 is 3. That means the constant term is 3, right? This is t, right? Cos x, x. Okay, so basically I of 0 is 3. Put x equals to 0. So I of 0 is 3. This is going to be c minus 6 upon 1 minus cos 0. Cos 0 is what? Not defined. So this is not defined. 1 upon not defined, 6 upon not defined is 0. So that's why c is coming out as 3. Okay. So now you have a function full-fledged I of x. 3 minus 6 upon 1 minus cot of x. That's it. Now I of pi by 12. So x is equals to pi upon 12. So that is going to give you 3 minus 6 upon 1 minus cot 12 is 2 plus root 3. Okay. All right. So this will become 3 minus 6 upon, this is 1 minus 2. So minus 1 minus root 3. So plus root 3 plus 1. If you rationalize, what will you get? 3 plus, okay, rationalize. 3 plus 6 root 3 minus 1 by 2. So this is 3 root 3 minus 3. So 3 root 3 is absolutely right. This is going to become 3 root 3. Perfect. Yes. This question also done. Second question done. Now we are having this question. Okay. Yes, this is my favorite question. Okay. So this is not a general substitution. This is actually, you have to apply your brains. Okay, let me just write it. X minus 1 raised to power 1 by 5. Sorry, it is 4 by 5. And x plus 3 raised to power 6 by 5. Okay. Very like typical question that we have already done in root series as well. Dx, let's not forget. Now, what is so special about this? Just understand the powers. 4 by 5, 6 by 5. These two are the powers. If you add these two powers, although you cannot add, but if you add, you are going to get 10 by 5. 10 by 5 is 2. That power. So there is a reason why they have given us 4 by 5 and 6 by 5. But can you add those two powers? No. Why? Because the basis, that is, these two are very different things. If at all, you have, basically what I'm trying to say is, in place of x plus 3, suppose you had x minus 1 raised to power 6 by 5. then your job will be very much easier or not? So yes, that's what you have to do. You have to introduce x minus 1 raised to power 6 by 5 upon x minus 1 raised to power 6 by 5. You are introducing that factor. Why? Because you want to club this and this together. You want 4 by 5 and 6 by 5 to become together. Okay. So now finally integration dx. So x minus 1 power 4 by 5 and x minus 1 power 6 by 5 is what? X minus 1 power 10 by 5. And now the rest two, remaining two are also forming a, can you see this is x minus x plus, these two are having same powers. So x plus 3 upon x minus 1 is having power 6 by 5. Now, fun part. Now just tell me, if I put, okay, let me put on the another page. If I put x plus 3 upon x minus 1 as t. Now the people who have done a lot of practice in integration, they will understand this. If you put x minus 1 upon x plus 3 upon, sorry, x plus 3 upon x minus 1 is equals to 2. And if you start differentiating, you know what are you going to get? In quotient rule, denominator has x minus 1 whole square. That's exactly you want. See, dx upon x minus 1 square is already there. Then we are having x plus 3, x minus 1 power 6 by 5. So if I take x plus 3 upon x minus 1 as t, differentiate. So ma'am, x minus 1 whole square. X minus 1 as it is. X plus 3 derivative is 1. X plus 3 as it is, x minus 1 derivative is 1. This is equals to dt and this will be with dx. So x cancel, minus 1 minus 3 is minus 4 upon x minus 1 ka whole square dx is equals to dt. So dx upon x minus 1 ka whole square is dt upon minus 4. Now you're going to get, okay. So this is dt upon minus 4, correct, and this is your t raised to power 6 by 5. So finally you are getting dt minus dt by 4 t raised to power, t raised to power minus 6 by 5 dt upon minus 4 integral, right? So t raised to power minus 6 by 5 plus 1 upon minus 6 by 5 plus 1 into 4 plus constant, integration done, okay? Now just tell me, t raised to power minus 6 by 5. It is going to be 5. So minus 1 by 5. T raised to power minus 1 by 5 on minus 1 by 5 into 4. So this is minus into minus 4 plus c. So this is going to be t raised to power 1 by 5 minus minus plus. This is 4. This is 5. And plus constant. Now it's absolutely perfecto. Now we are having 5 by 4. You put the value of t right here, which is x plus 3, and this is x minus 1 raised to power 1 by 5 plus constant. This is your final answer. Now. You just have to compare, huh? You just have to compare. So finally, clearly, if you compare, a is coming out as 5 by 4. So a is 5 by 4. Then alpha x minus 1, obviously, alpha is also 1, beta is also 1. Alpha 1, beta 1. So 1 plus 1 plus, now power b. B is what? B, 1 by 5. Plus 20 into a. 5 by 4 into 1 by 5. 5 cancel. This is 5, 5, 6, 7. 7 seems to be absolutely perfect answer. Okay. All right. So, yes, this type of question, I would say you have to practice. So basically in integration, there are various types and you have to keep a track of each and every type. Okay. That's the whole point. That's the whole uh, conclusion. Okay. Now, 3 questions, 2 more to go. 2 more to go. Okay, so again, 2 minus tan x upon 3 plus tan x we have to integrate. And obviously, I have told you that whenever you see a p sin x plus, basically expression of sin x and cos x in the numerator mixed and expression of sin x and cos x in the denominator, what you need to do is you have to use this. What is this? Let's come back. First of all, let's convert this into sine and cos. So 2 cos x minus sine x upon 3 cos x plus sine x integral dx. Okay, so this will go a little bit lengthier. Yes, now what you have to do is numerator will be a times denominator. Let me do that for you. So numerator is what? 2 cos x minus sine x will be equal to a times denominator plus b times derivative. So minus 3 cos x plus, sorry, minus 3 sin x plus cos x. Okay. So yes, 2 cos minus sine is equals to, now collect the coefficient of cos. So ma'am, 3a plus b times cos and a minus 3b sine. Now just equate. 2 is equals to 3a plus b, that is first equation, and sin x ka minus 1 is equals to a minus 3b, this is second equation. If you solve these two, you are going to get a equals to, a will be your half and b also will be your half. Okay, है ना? A half, b half, yes. है ना? Two equations to unknown that you can solve. A half, b half, yes. So now this is your numerator. This numerator will be replaced by this right hand side which you are seeing, है ना? So yes, a times, so मतलब half times, half of denominator plus dx plus half times derivative of denominator upon denominator. This is also dx. And yeah, so integration can be, dx can be taken. Yes. So basically, what I'm trying to do is, yes, this numerator can be written down as half denominator plus half derivative of denominator. That's what we did. Upon denominator, clear, integral dx. This is also dx. Perfect. That's what we did. Denominator gone. Half ka integral is 1 by 2x plus. Now 1 by 2 is already there. Now if you put denominator as t, understand, huh? If you put denominator as t, so denominator is equals to t. So tell me, derivative of denominator dx will be equals to dt, right? Yes. So denominator derivative, this will be equals to dt only. Okay. So half dt by t ka integral. So half x plus 1 by 2 log of mod of t. What is t? This denominator is t, which is 3 cos x plus sin x. And you are done. Now you just have to compare, right? So obviously half is there. If you take half common, just tell me. If you take half common, so half x plus log of mod of 3 cos x plus sin x plus c. Clearly alpha is 1. Alpha is equals to 1. Clearly log b plus gamma, right? So log of beta. Beta is 3. And sorry, beta is 1. Beta is 1 because sin x coefficient is 1. And gamma is cos x coefficient is 3. That's it. That's it, right? They are talking about alpha plus gamma by beta. So 1 plus gamma, 3 by 1. So 4 is the correct answer. Option B, 4 is absolutely right. And last but not the least, okay. Last but not the least, this question which we were talking about, okay. Recurring integration, okay. Cosec raised to power 5x, okay. All right. So now again, I told you that this is a little bit lengthier. So first of all, let's break it down. This we have done in road series also. Road series indefinite integration part 1 ka the very last part. Go and watch it. You will understand. Cosec raised to power 5. So what I'm going to do is, I'm going to write it as cosec cube x, cosec square x. Okay. And by parts I will apply. Recurring means what? By parts only. So this is your first function. And this is your second function. Always second function will be that function whose integral you know, and you know cosec square ka integral, right? Minus cot x. By parts says if whenever you have to integrate first and second function, it will be first function constant, integral of second minus integral of first ka derivative, second ka integral. That's it. So now cosec cube x, first function constant, integral of second minus cot x minus integral of, by the way, this is I. Let me take as I. Whenever there is a recurring integral, always take I. So first function constant, integral of second minus integral of derivative of first function. Derivative of cosec x is cosec x cot x with a negative sign. Okay. And now integration of second, so cosec square ka integration will be minus cot x dx. Clearly these two minus will get vanished only. 2 minus cancelling both the minus. Yes. Now I will be equals to minus cot x cosec cube x minus 3 times integral. Now this time cosec cube is there, cosec cube x, and cot square x is there. Now let's expand cos square x. Okay, I can see the recurring integral is getting formed. Cot x cosec cube x minus 3 cosec cube x cosec square x minus 1. This is what cot square x is. Dx integral is already there. Clearly, if you, the moment you multiply, now clearly minus 3 is already there. Now, if I multiply these two, I get cos power 5x. So, integral of cos power 5x directly substituted as I. The second term which you are getting minus minus plus 3 cos cube x dx. This you have to. Now again, this is a separate problem. Let us leave it here. Let us leave it right here. Okay. And also minus 3 I na, so it will become 4i is equals to minus cot x cosec cube x plus 3. Let us mark it as I1. Or let's do one thing. Yeah, cosec cube x. Na? Cosec cube x that we have to figure out. Now integral of cosec cube x is I1. Same thing we have to apply, okay? So yes, this is going to become integral of cosec x and cosec square x. Always separate cosec square x. Always. First, second. Okay. Why second? Because we know the integration of cosec square, right? Okay. Although we know integration of cosec x, but cosec square integration is very simple. First function constant. Second ka integration, so minus cot x minus integral of derivative of first. So cosec x ka differentiation is cosec x cot x with a negative sign, and integration of this will be minus cot x dx. Can you see? I1 is equals to minus cosec x cot x. Then we have minus sign, and we have integral cosec x cot square x dx. Again expand this. The moment you expand, again you're going to get a recurring integral. Okay. So this is going to become integral of cosec x cosec square x minus 1 dx. Now just multiply minus cot x cosec x minus, now the moment you multiply, you're going to get I1 minus minus plus again integral of cosec x dx. Now you know integral of cosec x, right? So integral of cosec x will be log of tan x by 2. Okay. So this is going to give you I1. I1 will be 2I1 minus cot x cosec x plus log of mod of tan x by 2. Right? 2 is gone. So this is 1 by 2. This is also 1 by 2. So I1, which is, you just have to put the value now, right? Minus half cot x cosec. So this is going to be minus half cot x cosec x. Okay. Then we have plus half log of mod of tan x by 2. plus constant, obviously. And now the last step would be this 4 will be gone from here and it will be upon 4. Now compare. Compare. So clearly it is clearly observe we can observe that this is alpha cot x cosec cube x. Okay, so alpha will be something which will be the coefficient of cot x cosec cube x. So that is minus 1 by 4. So alpha is coming out as minus 1 by 4. Okay, then we are having plus 3 by 2 alpha cot x cosec x. So 3 by 2 alpha is the coefficient of cot cosec. So 3 by 2 alpha. So 3 minus 3 by 2 upon 4. So 3 by 2 alpha is equals to minus 3 by 2 upon 4. So clearly 3 by 2 gone again. Alpha is minus 1 by 4 matching. Now next. So this is sorted. Plus beta log tan x by 2. So tan x by 2 ka coefficient is what? 3 by 2 by 4. So beta will be 3 by 2 by 4. So 3 by 8. Absolutely. So 8 alpha is what? Minus 2 by 8 can I write? Minus 1 by 4 is what? Minus 2 by 8 plus 1 by 8. Right? To take LCM. So this is going to become okay. Is it coming negative or what? Sorry, this is 3 by 8. Yes. So this is 8 gone to 1. So answer is 1. With this question, we are done with all 5 questions of indefinite integration. And yes, if you are having any doubts, you can reach out to me on t.me/Namrata Jaisinghani. And obviously, I have made a WhatsApp channel because we don't know Telegram is a little bit dicey. So I have sent a link on this channel only, this Telegram channel. Just go and follow me on WhatsApp as well for safe side. And second, yes, so 2024 PYQs, so we are anyway doing. But what we are lacking is 2022 and 2023 PYQs. Last 3 PYQs is bare minimum, right? Once you are done with that, then think of 2021, 2020. All right, are you getting my point? So yes, what you need to do is you need to buy Tatva books. Yes, you need to buy Tatva books, which is having chapter wise JEE main PYQ, which are error free. Okay, so very concise, very precise solutions will be there in Tatva JEE main PYQ. Link is given in the description box. And also do follow the ROAR series, wherein we are already doing one shot sessions. Detailed one shot sessions are there for in that series. So roar series, follow, go and check out the playlist also. And yeah, so that's about it. And also let me know next which chapter you are going to you want that chapter to happen in the PYQ series, so that I'll bring that video for you as well. This is me, Namrata, signing off. I'll see you all in the next video.